Hello everyone, welcome back to another episode of Space Store Live. I'm Abby from Space Store and we're with Nick and Terry. So thank you everyone for joining us today. Welcome back to another episode of Space Roundup for tonight, bringing you the most exciting space news stories from the last couple of weeks, and also what to look up for in the next couple of weeks. Thank you for taking time out of your Tuesday evening to spend with us, and I'll pass over to Nick and Terry now for what I'm sure will be another great show.
Cheers, Abby. Thank you. We got another cracker. We're always finding good stories. Terry's going to lead with this one I absolutely love, and then it's going to get a bit apocalyptic, but yeah, let's just crack on. Over to you, Terry.
Everybody loves a good apocalypse. Yeah, there's so much in this story, and it's just new that I'm going to have to refer to notes. It's basically the nearest black hole to Earth has been discovered, and it's really near on the cosmic scale, on the galactic scale, and it's really amazing. You could actually go out and look with your telescope and not see the black hole itself, but see a star that's orbiting it. So I'll say more about that later, but that's how close it is to us. It's called Gaia BH1 for Black Hole 1, and I'll come to the Gaia bit in a minute. It was discovered by astronomers at the Harvard Smithsonian Institute and the Max Planck Institute in Germany. It's got 10 solar masses. And how did they discover it? How do you discover something that's black? Well, what they did was they searched data on 200,000 binary stars from the Gaia catalogue. It's a satellite that has revolutionized our knowledge of the galaxy, imaged millions of stars, given us a lot of very detailed information about their positions, their motions, their spectra, and so on. So what they did was they looked for binary stars, and other stars that's one of a pair, with a little bit of a wobble, but one where they couldn't see a companion. And that therefore indicated that the companion might be either a very, very faint star or a black hole. And they spotted one that seemed to be a really good candidate, a star quite like the sun, similar spectra, similar size, which was orbiting something that couldn't be seen. There was a wobble there, but they couldn't see what was causing the wobble. So they then used some of the biggest telescopes in the world, the 10-meter and 8-meter class telescopes, the Keck and the GMT and the Gemini in Hawaii and Chile. And they studied the spectra of the star that they could see. And the presence of the black hole was revealed by the Doppler shift in the spectra of the star. So basically, you have the things going around each other like that. One of them you can't see, but the other one you can. And as it moves towards you, the spectra of that star is shifted towards the blue end of the spectrum, and as it moves away, shifted towards the red end. So that's a classic technique in astronomy. And it showed that it was indeed orbiting something that wasn't visible. They worked out it was about 10 times the mass of the sun. The orbital period was 185 days, and the distance between the two objects was approximately the same as the distance from the Earth to the sun, 1 astronomical unit. So there we are. We have an object, mass of 10 times the sun and not visible. It's not 100% certain, but it's 99.5% certain it's a black hole. There's nothing else that can really explain that. So the interesting thing is this one is really close. Now, astronomers talk huge numbers, so it's not in your backyard, except sort of galactically speaking. It's 1,550 light years away, and a light year in miles, approximately 6 million. That seems very, very far away, but it's actually 1,000 light years closer to us than a star that most people that know the night sky will know, Deneb. So Deneb is about roughly 2,600 light years away, and this one's about 1,000 light years closer to that. So that shows it really is quite close on the galactic scale. And I did a little bit of research on this, and anybody with a really good telescope could go out and find the star. All the details are on Wikipedia to give you the exact right ascension declination, enable you to find it. With a decent sized telescope, you'd certainly see a star. It's about magnitude 13.8. I've certainly seen stars much fainter than that in various telescopes. Or if you have an even smaller one, but a good CCD camera, you can image it. So it's almost mind blowing to think. It's in Ophiuchus, by the way, quite close to the celestial equator. Now, you will need the exact position to be able to locate it. But you could go out, in theory, tonight with your telescope and see the star, which is orbiting around. You won't see it moving yourself, but see that star and know that that is orbiting a 10 solar mass black hole in our sort of backyard in terms of the size of the galaxy. I think that is absolutely amazing. By the way, the diameter of what we call the event horizon, the area within which everything becomes invisible, the Schwarzschild radius, is about 17 miles. So you know London better than I do, Nick. That would fit roughly inside the M25.
Just about inside
right?
the M25.
Yeah.
So
I think this is just mind-blowing. The thing is, there could be others even closer to us that we're not aware of because they literally are invisible. And the only way we can detect them is if they merge with something and emit gravitational waves, or if we find one which is orbiting another star and we can see that star wobble, but there's nothing there to make the star appear to wobble visually. And then you look and see if there is something like a black hole or maybe a neutron star there. But in this case, they're 99% certain it's a black hole. And this is just mind-boggling stuff. I mean, 20 years ago, this was science fiction, and now we're seeing it happening in front of us. So I'm sure you're as excited as I am, Nick.
Yeah, I mean, it's the proximity. I mean, I've looked at, and I guess you have as well, Terry, and imaged things like M87, which is a classic galaxy that's got a superluminal jet basically emitting from it, being created by what's happening in the core of that galaxy, in the supermassive black hole that's there. We know that there's a supermassive black hole in the center of our own galaxy. But we've got something here, as you said, 1,550 light years away, which is an absolute, it's like chucking a stone across a pond in terms of the distance in the known universe, as it were. What's interesting is, as you said, the way it was detected, because typically with black holes, you're looking for X-ray emissions, because you've got so much energy basically forming around this, the event horizon, the core collapse, the outer regions, as it were, where it may be sucking material off a nearby star. And that's the other interesting thing, because it's near to another star. is its gravitational field, will we be able to one day see, potential streamers coming from the other star going into and being sucked into this black hole? And you think about how, certain stars orbit each other. I was looking at the double, very famous kind of twin binary system, very beautiful to resolve if you want a challenge for your telescope in terms of the separation of these two stars. And you think about the proximity of the stars. Our nearest star, apart from the sun, obviously, is Proxima Centauri, at around about 4 light years away. We're looking at vastly closer distances in this, and you can imagine the turmoil that's happening in any potential planetary system that's near this. But as I said, it's the lack of X-ray emissions and the fact that there could be more. This Doppler method is now becoming so advanced, between the orbiting telescopes and the ground-based telescopes and the incredible resolution that we now have, this ability, either through Doppler shift or through spectroscopy, to be able to detect not only interactions between planetary systems and stars, but also, as you said, these hidden objects, potentially, and anything larger than a few tens of solar masses is potentially going to turn into a black hole. So, yeah, it's not only interesting, it's terrifying as well, because something that close, you imagine the energy that would have kicked off from that when that went into core collapse and formed a black hole. And you were saying about gravitational waves. If you've got two binary stars that eventually do kind of collapse into each other or form a collapsing, merging black hole system anywhere near us, the gravitational wave from that is gonna trigger everything. All the LIGOs and things like the LISA spacecraft, which European Space Agency are hoping to launch in a few years. It's going to be incredible. Yeah. Really incredible.
I forgot to mention, they were thinking that the progenitor star was about 20 solar masses. Yeah. So that's one of the ones that live fast, die young. They burn away all their mass very, very quickly, and as you say, become a super big red giant, flow off the outer layers, and the inside collapses. That's what they reckon happened with this one. So as you said, if there's a planetary system there, they've been going through interesting times.
And as you said, it's one of those ones that you can go out and look at the star. So, RA and deck position's really quite simple if you've got a good go-to telescope, or if you're pretty hot on celestial navigation. But with a go-to telescope, you'd easily get it in the field of view. Yeah. I'm going to be at the Blackett Observatory at Marlborough College in a few weeks on the 18-inch telescope there. That is going to be the visual target, absolutely, undoubtedly, on that. But yeah, fascinating, absolutely wonderful story, this one. Yeah. Moving on to our next one, where it gets really apocalyptic. So this made all the major news channels in the United States and a lot of the newspapers over here in the UK, and I guess in the United States as well. This whole thing with potentially hazardous and planet killer asteroids. And when they say the word planet killer, everyone goes, "Oh, we're all going to die." We're not. But it is a real concern, this. It's not kind of hyperbole, as it were. This is a genuinely concerning object. So effectively, Carnegie Institute and a few other astronomy groups around the world with professional telescopes, typically when you're looking for new comets, you're looking for new asteroids, you're pointing out of the solar system. So you're looking outwards towards Jupiter, Saturn, etc., and you're not looking really in sunward. Things like the James Webb Space Telescope, the Hubble Space Telescope can't even point anywhere near the direction of the sun because the damage to the telescope, etc. And this is a really tricky area to observe. When you've got objects that are basically orbiting the sun around a similar kind of orbital orbital period, as it were, or potentially Earth crossing orbits, and they're on the other side of the sun, really, really difficult to find. We found that with Chelyabinsk back in 2013 in February, when an asteroid literally came out of nowhere. They were looking at another one called, I think it was 2012 DAE-14, which was about the size of a battleship. They were looking at one asteroid, all the astronomers, and then another one around about 17 meters wide came in and airburst over Chelyabinsk and broke thousands of windows and injured thousands of people, etc., etc. But thankfully, it wasn't that big. This one is that big. This one is, as they say, what is called a planet killer. Why is it a planet killer? Well, this one is anywhere between 1.1 and 2.3 kilometers in size. Now, the one that wiped out 90% of all life on Earth 66 million years ago was around about 10 kilometers in size, so we believe. So at 1.1 to 2.3 kilometers, it's not quite that big, but it's big enough to cause a catastrophic effect on the Earth's surface. If it were to strike the oceans, you'd have tsunamis thousands of feet high, traveling at thousands of miles an hour, basically wiping out all coastal regions along wherever they hit. So if it hit mid-Atlantic, you take out the eastern seaboard of the United States, you take out western seaboard of Africa, the Canary Islands, etc., etc. Pacific, obviously, you've got Hawaii, Japan, you've got the western coast of the United States. So that would be bad enough. But if it were to hit land, and there's a wonderful thing called the impact calculator, the impact on land would create tsunamis on land. You'd be talking about debris being basically wave shocked out and masses of debris thrown into the upper atmosphere, which would then block out the sun, cool down the planet. So if you want to avert global warming, that's one way to do it. But it would block out the sun, cool down the planet, disrupt the entire food chain. So the plants would die, the animals that feed on the plants would die, the animals that feed on the animals would die, and it would just be incredibly bad. When they were looking towards the sun with these like telescopes, essentially what they're doing is looking at this kind of interface period, twilight, kind of sunrise, sunset, when the major part of the sun's glare is below the horizon, but you can look inwards towards the sun. They found 3 asteroids. Thankfully, only one of them, which is now called 2022 AP7. 2022 because the year of discovery. AP7 is basically the date and day within each month. It's how basically comets, asteroids are given their nomenclature. So AA1, for example, potentially early January, AP7. It kind of progresses its way through the year. So that's how, with comets in particular, that's how they're named. As I said, 1.1 to 2.3 kilometers wide. This is quite a significant object. This kind of size realistically only hits, and looking at some of the data for this, the Earth every 500,000 to 1 million years. But we are long overdue one. We've not had a big impact that we are aware of that's been catastrophic on this kind of scale for the last 66 million years. Now, if you think that our solar system is orbiting the galaxy every 250 million years and dipping up and down through the galactic plane, etc., we've not only got to worry about the threat of this, we've got to worry about the threat of comets and the Oort cloud and the 8 trillion objects in the Oort cloud and, extra solar objects at Oumuamua. We talked about that last time. But it is really tricky. Finding these objects, NASA and various other astronomers around the world think that they've catalogued around about 95% of the planet-killing asteroids that aren't on the sunward direction. But these just came out of nowhere. They were literally, completely undetected before. Now, the thing with this one is, yes, it is going to cross the Earth's orbit. It is a threat. When it comes to things like the Torino scale, which is how we measure the threats, it's quite low at the moment. And this is where missions like DART are genuinely important. So the DART mission, which we covered a few months ago, was the one where NASA threw a small spacecraft into an asteroid which was orbiting the Dimorphos system, basically to try and deflect the asteroid and change its orbit. And it did by fractions of a second, but it was able to change its orbit with the impact. With this object, we know, due to its Earth-crossing nature and the fact that it is on the other side of the sun, it's not going to impact us potentially for 100 to 200 years minimum. And the orbit's been refined all the time. That may increase, that may decrease, we don't know. But it's this threat that these kind of objects are still being detected. And what we need to now work on is, a long-term strategy. If an asteroid like 2022 AP7, if they say, right, well, in 180 years or 220 years, it is going to potentially cross the Earth's path. It's going to have a high Torino value. It could strike us. It could wipe out all life on the planet. What are we going to do about it? If we've not already killed each other, all life on Earth by then anyway, with the likes of what's going on in Ukraine, etc., what do we do about it? And as I said, things like DART, if we can deflect it this early on, then you can change the orbit sufficiently. This is where these kind of missions are really, really, really important. I don't know what you think about this, Terry, but it's again proof that it's a really critical part of astronomy, and the fact that looking in sunward is still so difficult, it almost beggars belief that we don't have a more advanced. I know we've got things like the SOHO satellites orbiting at Lagrange points and observing the sun and looking out for potentially hazardous solar storms and solar events, but I think we need more telescopes that would effectively be in orbit, giving us this capability to really scan, the orbital areas, near Venus, near Mercury, etc., and to look for these things that potentially are planet killers.
Yep. There's good news and bad news, as they say about this one. It's actually in a special sort of orbital resonance with the Earth, a 5-to-1 orbital resonance, which means that for every orbit of the Earth, the asteroid does 5 orbits, and they come back to exactly the same, well, almost exactly the same relative position. So this one isn't going to hit us in the foreseeable future, but those resonance orbits are not entirely stable. It only takes sort of a bit of a change in some of the other planetary orbits to start putting that out of the exact resonance that we have. The scary bit is that it took so long for us to discover this object because they are so hard to find. And the implication of that is that there could very well be others in there that we haven't discovered yet, and they might actually be ones that could potentially hit us in the near future. The other interesting thing is this was discovered by a camera that was designed for something else entirely, the dark energy camera. We're not going to go into the dark energy debate, but that mission is finished. So they're now using that camera, which is a pretty powerful one, to look for other things. And as you say, they found 3 of these very quickly, and that indicates that there could well be others in there that we still have not discovered. You simply can't see them at all if they stay very close to the sun and the sky. They need to come out, a bit beyond the orbit of Mercury, maybe not quite as far as the orbit of Venus, for you to be able to see them in a relatively dark sky. So what we need actually is a telescope on Mercury pointing outwards, and then we'd be able to discover these. I don't think there are any plans for that at the moment. But yeah, as I say, this one isn't going to hit us in the foreseeable future. But the scary thing is there could be others there, perhaps even bigger than that one that we haven't discovered yet.
You talk about orbital resonances as well. You only have to look at the sheer number of sun-grazing comets and comets that are detected by things like SOHO, etc. And you forget that it's not only us that can be hit by other objects, it's other objects orbiting that can be hit by other objects. So whilst an orbit may be stable right now and you think, well, it's not going to be a threat, it only needs a collision on that orbit, much like the DART mission proved with NASA, where they deflected an asteroid. If you were to have an instant collision from a cometary body or another body that, as you said, Terry, we don't even know if it exists yet, between these, potentially hazardous asteroids that could change that orbit to such an extent. I mean, we've really got to be looking all the time. That's the key point here. Really got to be looking all the time. Anyway, moving on.
Right. E.T., everybody's favorite alien. What do we do if E.T. phones us? Well, as everybody knows now, you don't use your phone for actually phone calls. You use it for messages. The last time I actually had a phone call on my mobile was quite a long time ago. But being serious, what happens if we do get an absolutely clear, unambiguous message from another civilization elsewhere in the galaxy? There's a lot of speculation about this. There are no easy answers, but there's some progress now being made along what we should do if this sort of thing happens. So let's say we get a message from another civilization in the galaxy. They won't be speaking English or Esperanto or Chinese or anything like that, but hopefully it will be in some sort of a language, a mathematical language or a symbolic language that we can decode. In any case, as long as we can tell that it is an intelligent message, even if we can't decode it, that tells us that there is intelligent life elsewhere in our galaxy. And that raises all sorts of questions. What do we do? Do you treat it like a scam message on your phone or your computer and ignore it? Do we just analyze it and say, right, we know where it came from, and that system is X light years away, and that means that the message must have been sent X years ago, and not do anything more? Or do we answer it? If we can, assuming that we can try and decode it in some way. Even if we can't decode it, if we know it's an intelligent signal, we could try sending a signal back again to whoever sent it. So the question then follows, if we decide to answer it, who answers it, and what do we say? Because it's not just as simple as that. If you watch any of the science fiction films, you'll know that it's quite possible that there are other civilizations out there in the galaxy who don't necessarily regard us with the best of intent. And in fact, we only have to look at our own planet Earth here. Whenever some of the leading civilizations, as they were called at the time, went out to discover new countries, new continents, and so on, it didn't always end too well for the original inhabitants of those parts of the world. Now, 35 years ago, there was actually a protocol set up by SETI, an organization called the Search for Extraterrestrial Intelligence. It's now very much out of date. And what's happened now is that the University of St. Andrews have set up what they call the SETI Detection Hub. And it is to address this problem sort of nowadays in the light of latest information and perhaps some more rational way of thinking about things. So the first thing that they will be thinking about is what will the impact be on humanity in getting a signal from another civilization elsewhere in the universe. It means definitively that we are not alone. We are not the only intelligent civilization in the universe. And that has all sorts of philosophical implications. It could be sort of a culture shock, particularly if they turn out to be a lot more advanced than us. So some people would say, well, actually be better for humanity if we didn't even reveal the fact that we had discovered this, but it's going to be almost impossible to keep it quiet. It has religious implications in terms of the main monotheistic religions, which say that we are specially created and all the rest of it. Nothing in the Bible or the Quran or the Torah or whatever say anything about life elsewhere in the universe. So there's implications of that. The other thing is, if we respond, we are giving away the fact that we are here and where we are in the galaxy. And if they don't already know that we're here, which is possible, they may have just sent out the signal hoping that somebody will pick it up. If we reply, we are saying, yes, we are here. We're a moderately advanced technological civilization. We hear you and we've sent you a message back. And this is where the danger of that other civilization perhaps having ill intent towards us. Now, it doesn't mean that they're going to come here and mine us for minerals, although that's a possibility. But probably, if they wanted minerals, they'd go straight to the asteroid belt if they didn't have one of their own. But nevertheless, we could be revealing our presence to another civilization which is a lot more powerful, a lot more advanced than we are. There's another possibility, and that is that message might be some sort of an interstellar virus or Trojan, which would completely wreck our terrestrial communication systems. We have absolutely no way of knowing until you sort of click on the link, as they say. So anyway, the protocol is going to be along the lines of, first of all, if we get it, the scientists that get it should report it to some independent body, probably the United Nations, although what the UN can do about it is another matter. But we certainly need to have a global response. We don't want, say, if the Spaniards are the first to pick it up, they decide off their own bat that they're going to reply and then, as I say, possibly expose the Earth to the threat of some sort of danger from another civilization. If we do reply, what do we say? Do we say, nice to meet you? Or do we say, what is the answer to universe, the life, and everything? Or, literally, what do you say? Yeah. So the problem is that nobody really has any idea what the situation is at the moment. If, say, either America or Russia or China or ESA or somebody picked up that signal, they could, at the moment, off their own bat, decide to reply to it. And that then, as I say, has implications for the whole planet. So it's probably best if we have an agreed protocol with all the major countries that are liable to possibly pick up such a signal to say, right, this is what we do. We notify the United Nations. The United Nations needs some sort of a subcommittee or something like that set up to decide then what we do. And then, if necessary, we send a signal back again. The other thing is that, of course, the time scale could be very, very considerable. If it comes from a civilization orbiting a star 100 light years away, it'll take 100 years to get to us. Probably take at least a year before we make up our mind whether to reply or not, and we send the signal back. That means it's at least 200 years before the people that sent the signal get it back again. Will they still be there? Will they have blown themselves to pieces? They might have sent it out as a civilized society, but there might have been a revolution, and suddenly you have somebody like, well, I'm not going to mention names, but a certain gentleman that's a lot in the news at the moment with belligerent intent. So there could be a change in the civilization that sent that signal. So all sorts of angles that need to be thrashed out by far brighter brains than mine. But it's encouraging, I think, that somebody is actually addressing the problem. They're going to make recommendations. Whether it ever gets as far as the UN and whether the UN ever decide to actually do anything along these lines, we don't know. But at least we're making a step in that direction. So I'm sure you've thoughts on it, Nick.
the major thinking on this is that science fiction again becomes science fact at some point, in that, for decades now, from H.G. Wells onwards, as you said, War of the Worlds, looking at us with envious eyes, and that was just Mars. We've kind of imagined the concept of an alien civilization either approaching us, and you got various conspiracy theorists and everyone believes that Roswell happened, yada yada yada. But the real science behind this is something we do need to address. There are 250 billion stars in our own galaxy. There are 250 billion galaxies. There are 8 planets orbiting this star that we call home in the sun. So, the chances of there not being life out there are ridiculously slim. It's just not even worth thinking about. There is definitely life elsewhere in the universe. The level of intelligence in that life is another good point, because what we classify as intelligence is based upon a bipedal, hominid figure that can, send and receive text messages and do TikTok videos. That's what we perceive as intelligence. But then you look at ant colonies, you look at whales, you look at dolphins, you look at the creatures on our own planet, that we can't even communicate with creatures on our own planet yet. We can barely talk to, man's best friend, the dog, as it were, and we can, barely communicate with something that we're supposedly that close to. We don't have any idea in terms of communication between advanced animal life, like, as I said, dolphins, chimpanzees, etc. We know that they have social structures. We know that they hunt in packs. We know that they do various things, but we can't communicate with them. So this notion of being able to communicate with an extraterrestrial intelligence, again, unless we're talking about, transmitting much like the SETI signal did, where you're transmitting kind of basic mathematics and basic laws of physics, which should, in theory, apply everywhere else in the universe. But it depends, obviously, on how a nominal civilization, intelligent civilization, does interpret that. We interpret, base 10 because we've got 10 fingers. We have a year because it's 365 days for our planet to orbit the sun. So the kind of things that are human constructs, time is a human construct. Let's not forget that. We invented time to explain, certain events, seasons, to explain the sun rising and the sun setting. Time may mean something completely different to an alien civilization. We have no idea. It probably means a lot of different things to, life on this planet. You look at the mycelium and, underneath the tree roots, and the whole, wondrous kind of advances we found in terms of psychosilic and mushrooms and all of the other things, and how they communicate. The mycelium underneath trees basically communicating with each other over these vast networks. We can't even begin to comprehend what's going on our own planet yet. So whilst it's great that the likes of the United Nations, etc., will be involved, and you do need a unilateral, a kind of global response rather than a singular unilateral response, as you said before, you need the whole planet to get behind this. But again, it's much like the asteroid threat. We need to have a unilateral, a non-unilateral response to that. We need to have, a global agreed, what are we going to do? Because if America suddenly decides, we're going to send up nukes and we're going to try and nuke an asteroid, what are the Russians going to say? What are the Chinese going to say? As you said, communication with an alien life form. You only have to look at, good or bad science fiction movies like Independence Day and V back, the TV series back in the early 80s. And communicating with an alien species, and then they basically came and ate us. We don't know. We don't know what's going to happen. So yes, it needs considerable thought. And it sounds like a joke. When I first saw this story, I thought, oh, here we go. It's kind of another conspiracy theory, kind of hokey, but it's a genuine thing that we need to think about, especially as we get more advanced, as we're able to send out deeper and deeper spacecraft. The potential for sending out solar probes where we can accelerate them up to 1/10 light speed. And can you imagine if you're on another planet orbiting, say, 20, 30 light years away, and in 60 to 100 years or whatever, something flies by, because we've sent it there. What are you going to do? What are you going to do? And then the other thing is, this idea of SETI, as you said, it is a very outdated concept, because if you think about communication on this planet, we've had radio communication in the 4.5 billion years of the existence of this planet. We've had radio communication capability of the power that's needed for about 100 years. That's about it. So in effect, we're almost saying, well, if we use radio waves, we can communicate. Well, it's ridiculous, because along the timescales of any other civilization or any other planet in the entire universe, we have no idea where they're going to be. So I mean, I've always thought, looking at the spectra of other planets, things like the James Webb, being able to determine if, you know, the spectroscopy of another planet could support life is one, you know, interesting way that if we were to target, and this is the other question, we've already sent out messages, we've already been broadcasting, you know, as we saw in Contact, you know, fantastic film, fantastic book by Carl Sagan. We've been broadcasting now, you know, with sufficient power since the 1920s, 1930s. So we've already been saying, hello, we're here, you know, for quite some time, and somebody else could respond and say, oh, well, this planet here has been broadcasting, and, you know, the premise in Contact was you had, you know, the Nuremberg rallies being broadcast. If they were to see that, and you were saying about nefarious, you know, actors, as it were, on another planet, if they were to look at that and say, oh, hold on, this looks a bit bad, we may need to wipe this planet out because this guy looks really bad, but not understanding that that guy is long gone. It's a really, really interesting, as you said, philosophical discussion. More so almost than a scientific discussion, but the science is really important. The scientific response and how we deal with it and how we communicate back to an intelligent civilization. You know, they could have orbiting kind of giant mirrors, almost that like the beacons, semaphore beacons that you had on ships. Instead of using radio, they just blink, but they blink in such a way that it's almost like a Morse code signal, that there's nothing, you know, natural that could create that. So, and then the question is, as you said, if it's more than, say, 70 or 80 light years away, what do we do? Because no technology we've got right now is going to be of any use to us whatsoever. Even if we could accelerate anything up to, say, 1/10 light speed, which is potentially doable right now, you're looking at, what, 700 years? 500, 70 years, whatever. Unless it's at Proxima Centauri, there's a planetary system there that, you know, has got life on it that we just don't know about. And again, it's what do you call intelligent life? There could be intelligent life below the surface of Europa. There could be, you know, an advanced form of, I don't know, some kind of small whale or whatever, swimming around quite happily underneath the surface of the ice floes on the ice sheet on Europa. Who knows? We just don't have a clue. And I think addressing communication disparities and communication issues on our own planet is equally as important as it is trying to communicate with, you know, extraterrestrial life. Because we, as I said, we can't even communicate with 99.9% of the other species on Earth as it is. So,
yep. Just think what our communication system may be like in 1,000 years from now, let alone 10,000. And that is quite likely the level that any other intelligent civilization is at. The chances of them being just 1 century, if you like, into the ability to transmit are infinitesimally small. There are other civilizations out there that are probably so advanced that we can't even comprehend it. And if we make contact with them, you know, it could be really a major culture shock.
Well, that's the thing as well. You only have to look at the Dark Ages and how that suppressed scientific thinking and scientific advancements on our own planet. You know, you had religious constraints. You know, don't want to go into the whole religion debate on this show, but you know, religious constraints during the, you know, the dark of the 12th, 13th, 14th, 15th, whatever, 16th, up to the 16th, 17th century even, were quite severe in that if you were an advanced thinker, you could be burnt at the stake. So the suppression, we could have been several hundred years ahead of where we are now had it not been for some of the suppression that we've had to undergo as a species and as humanity. So who knows? Who knows what, as you said, it's ridiculous. It's so arrogant, I think, of, and I know Seth Shostak and I know Jill Tarter. They're great people. The SETI Institute have done some great work, but it's almost an arrogant belief that we can communicate in a means and method that is something we've only had for 150 years, and we're almost about to abandon it anyway. We're moving into digital transmission, laser communication, etc. Standard radio transmission as we know it probably won't exist in the not too distant future. So it's this really narrow time window, as you said, and our planet's been around for 4.5 billion years. So good luck on that one. And if it wasn't for the asteroid impact 66 million years ago, it'd be like Super Mario, if you've ever seen that awful Bob Hoskins film from the late 80s with the dinosaurs roaming around. Anyway, moving on, it's a really good one, though. It's a really interesting debate, and I think it's one that will probably roll on and on until the day when we do make first contact. And that's going to be quite profound. And I think, you know, you said about the religious implications and, you know, the monotheistic kind of religious beliefs that we have on a lot of the planet. Even if we were to discover microbial life on Mars or subsurface on Enceladus or subsurface on Europa, the implications for that are going to be profound for the people who have those very strong beliefs along those lines. Anyway, philosophy, religion, science, all intermingles, just don't get politics. Anyway, moving on, a lot closer to home and back to H.G. Wells's favourite planet. This is Mars and the InSight mission. So InSight, unlike some of the rovers, so you've had Perseverance, you've had Opportunity, we've got ExoMars now kind of hanging by a thread, as it were, and whether or not it's going to go to the moon or Mars. And obviously, future missions, NASA are going to be sending, potentially humans to Mars within the next 10 to 15 years. We hope Elon Musk, if he gets his way, will be sending them in the next 2 years, and they'll freeze to death and die and what have you. Anyway, unless you're obviously a fanboy and then nothing can harm you, or you're using Twitter and then nothing can harm you either. But Mars is a really fascinating planet, not just from the rover's perspective. NASA have landed some spectacular kind of static spacecraft on Mars all throughout the decade. So mid-1970s, 1976, we had Viking 1, Viking 2, which did incredible surface science just from a static landing position. And NASA didn't kind of give up on this. So they stuck the InSight lander down, and the InSight lander basically was designed to look at the planet's geology and seismology, and what's actually making up the planet and how it works, and whether or not it's still tectonically active. Now, it's detected hundreds, if not thousands, of mini Mars quakes so far, and it's really, really fascinating. But Christmas Eve 2021, its sensors went a bit, whoa, what's going on here? And it turns out, from orbiting data that is now being kind of analysed, etc., that a significant asteroid impact hit Mars. And had this hit the Earth, if this had hit central London, bye-bye central London. You were talking about London before, the 17-kilometre diameter of London within the M25 or thereabouts. This was spewing out debris 30 kilometres away, and large chunks of it as well. The interesting thing is this struck very, very close to the equator in terms of, NASA's put landers now all the way up almost pretty much to the poles, and has been digging down and finding not only carbon dioxide ice but water ice. This impact carved out a rather nice hole near the equator. I think it's around about 11 degrees north of the equator, and in doing so it uncovered water ice, lots of it, just below the surface. So impact crater wasn't particularly deep, wasn't particularly wide, but as I said, throwing out lumps of ice the size of houses, up to 30 kilometers away. You can see it in the image there. It's actually beautiful. You look at the Mars Reconnaissance Orbiter and the HiRISE camera and various other orbiters. We've got so many orbiters now going around Mars. It's fantastic in that we can almost do a regular update, as it were, and look at things like ice flows coming out the sides of cavernous walls, where you're almost seeing like water flow, but it's not. It's kind of almost like a slushy ice dribbling down the sides of canyons and large crater walls. And this one, a relatively fresh impact crater digging up surface ice. I think it's the Amazonia Planitia region, is where it was found. They think that the object that hit was around about 200 tons in size, and not huge, not even Chelyabinsk size. But the thing is, Chelyabinsk airburst at 17 meters wide. As an airburst, it generated the energy of several Hiroshima bombs. This, you're talking about tens of Hiroshima bombs worth of energy. So as I said, this hit in a major city on the Earth, and not particularly big, it would have been catastrophic. What's fascinating about this, I found, is that with the detection now and the uncovering of very close to the surface water ice, if we are going to land humans on the surface of Mars, this is going to be critical. Having the ability to generate, not only oxygen, but also being able to pull water from just below the surface to sustain life, to be able to, do a Mark Watney and grow some plants, is going to be critical. It's one of those things that you kind of almost dismiss it when you see it in the news, but the importance of this for the long-term human exploration and the geology of Mars is quite fascinating. On top of that, you've also now got, again from the InSight lander, the detection of active magmatic bodies underneath the surface of Mars, where previously we thought that most of Mars was dormant. Obviously, we've got the Tharsis region, we've got Olympus Mons, which is the largest volcano in the solar system, 16 miles high. The top of it is actually in space when it comes to Mars's atmosphere and size, etc. You've got something here which, is not only interesting from the impact point of view, but the continuing science coming back from this modest little lander that's really struggling as well, because it's solar panels on which it relies for its power, and like the rovers, which are now predominantly nuclear powered, the solar panels are getting caked in dust and their energy efficiency is dropping off significantly. But InSight just keeps on delivering, and it's had issues with its, its drilling capability, all sorts of little problems throughout the years. But I think it's one of those great unsung missions. I don't know what you think, Terry, but the detection of these magma pools and the detection of almost like active volcanism, as it were, or subsurface volcanism. Something's still going on beneath the surface of Mars, and it's also redefining how we understand the whole composition of Mars. The fact that they would find increased amounts of silica in the surface, where previously it wasn't thought to be high in silicates. I don't know what your thoughts are on this, Terry, but it's amazing.
Yeah. I think to me the most significant thing is that there's that amount of water ice so close to the equator.
Yeah.
We knew that there's a lot near the poles. I don't know whether we can zoom in on that picture again, but basically those white bits that you can see there in the photograph are actually blocks of ice that have been blasted out by the impact. And you can see there's a significant amount there. That crater is about what? 150 meters across and about 21 meters deep. Some of the stuff will have been buried. Some of it will have gone out of the shot of the photograph there. But if there's that amount of water ice in that area, that indicates there's more than enough water there to supply a future human base on the subject and on the surface. And also, of course, you can break down water into hydrogen and oxygen and use them for fuel. So it's very significant. There's a fantastic simulated video available on, you just search on the internet, showing a simulated fly around and over that crater, and showing all the ice blocks there. So the scale of the crater there, as I say, is about 150 meters. So those ice blocks are the size of sort of refrigerator size or bigger. And it's absolutely amazing that they're there. They won't last there indefinitely. They will gradually sublimate during the low pressure in the Martian atmosphere. By the way, that's another significant factor there. You get a lot more actual crater impacts on Mars than you would on Earth, because Mars' atmosphere is so thin that it basically hardly slows down an incoming object at all. If that object had hit the Earth, it would have disintegrated in the upper atmosphere with a minor airburst. But because Mars' atmosphere is so thin, it penetrated right down and slammed into the surface, which of course in itself also has implications for any future human activity on Mars. Because if you have a nice geodesic dome or something like that, and beautiful conditions inside with your sauna and your potatoes growing, whatever, and something pierces the dome, they're in trouble. Mars' atmosphere gives very little protection against impacts, and not against solar radiation and cosmic radiation and so on, but that's straying away from the topic we're talking about at the moment. The interesting thing is that they have discovered or detected quite a few of these impacts over the years. And that gives us an indication of the current cratering rate on Mars, how often the surface is hit. And you can then extrapolate backwards from that and say, right, if the cratering rate is X number of X masses over a century or a millennium, and you forecast that back, you can then see what the geological history of Mars has been over the last, say, million years or so, how much the surface is tilled or churned over by these impacts. So fascinating stuff. And it's amazing that, as we say, we got that impact, and then partly from the Lunar Reconnaissance Orbiter imaging and actually detecting the crater and interpreting the seismic data, they were able to detect, yes, the seismic waves that InSight detected came from that particular impact. Fascinating stuff.
It is, and what you alluded to as well, you look at the history, the geological history of Mars, and there's so much evidence now that at one point Mars was literally covered in water, not particularly deep, but giant, vast oceans or lakes. And there's evidence of this obviously from the rovers. We've got meteorites, NWA 869. I've got one of those sitting in the cabinets behind me. The Allen Hills 84001 showed direct evidence of percolates and water flowing through the meteorites. So we know that Mars was saturated and had a water surface in the past, probably before the atmosphere was stripped away. Issues with the magnetic kind of shielding, as it were, because it doesn't really have the same level of magnetic core that, you know, it possibly once had in the past, which could have protected the atmosphere. What, who knows? But the atmosphere was stripped away. Loss of atmosphere would have then obviously resulted in the inability for water to be sustained in a liquid form on the surface, which we believe was the case. So whether or not all of that water kind of drizzled into the subsurface, as it were, and some of it could still be liquid, some of it, you know, we believe is still liquid. We believe that there's slush, etc., below the Martian surface at various points that have been detected from some of the ground penetrating radar from the orbiters. It is fascinating. It is absolutely fascinating that the, you know, and again, it goes back to, is there still life there? If there's slushy water there and there's something, you know, the radiation on the surface, you know, life isn't going to survive, but subsurface, and you only have to look at what we've got below the surface of the Earth, and, you know, around hydrothermal vents in the deep ocean. Who knows? It is really, really fascinating. But, and I had an argument, not an argument, but a discussion with Carolyn Porco, our dear friend, who's a PI for the, you know, the Cassini mission and worked on Voyager, etc. And she was arguing about, you know, do we still need human astronauts, or can we just do everything with robotics? And my kind of argument is, well, you know, you only have to look at the Apollo missions and look at the geology that came back from Jack Schmitt and, you know, Gene Cernan on Apollo 17. Some of the incredibly important rocks even picked up by Neil Armstrong on the first mission. We need boots on the ground. We need human geologists. We need human exploration, because whilst a rover or a robot, you know, they're getting better and better and more advanced all the time, more autonomous. You know, there's no doubt at all that, especially for deep space missions like New Horizons, you know, we can't do that with humans yet. But for Mars, if we want to definitively say whether or not there's life on Mars, definitively look at if we can inhabit another world, going back to the moon first and then onto Mars, it's something, you know, Rusty Schweikart once said, it's innate in the human spirit, and we do need to do it. It's not just the exploration and the excitement, but the science, and I believe the capabilities, until we get, you know, maybe in 100 years' time, it'll be a different argument. Maybe we'll have, you know, VR-based, you know, exoskeletons where somebody, you know, stood in a room on Earth and they're controlling something that is, in effect, a robot human on the surface of another world. Yeah, could be that, but it's not as exciting. Nobody knows where they were the day that Voyager 1 encountered Jupiter. Everybody on the planet knows where they were the day that Neil Armstrong set foot on the moon. So
absolutely,
there you go. That's the argument on that one. Going back to, and just finally, before we go on to our look up, going back to the moon, we were hoping, yet again, it's like madness waiting for the day that never comes. Artemis is now back on the pad. We were hoping to bring you information and fantastic news of Artemis launching. We've hoped to bring you that for the last 3 months. It's still there. It's still not taken off yet. The cost overrun on this apparently is now more than the cost of a Starship launch, but we won't go into that. It's hopefully going to launch within the next week. What are we now, you know, second week in November. NASA are saying that they hope to launch around about November the 14th. So maybe by the next show, we will be bringing you information from lunar orbit, as it were. Don't forget, there's no humans on this. It's just an Apollo 8 without the people kind of orbiting around the moon. It's going to go further out than any human-rated vehicle has ever done before, which is interesting in its own right. But the cost implications for this, and again, this was part of the discussion with Carolyn Porco, the cost implications for this are astonishing. The cost overruns, etc., and given the current global crises and the cost of living crisis and the whole environmental crisis that we're undergoing, the justification for this, you know, if you think it's now 50 years, we're coming up to the 50th anniversary of Apollo 17, the last time that we had human beings on the surface of another world, which was December 1972. If it's taken us 50 years to do something, you know, technologically, you know, in some ways less advanced. Don't forget, with Apollo, we sent humans, you know, and this, yes, we will be putting humans on the ground, and the long-term vision, the long-term goal for this is more sophisticated than Apollo, and the technology is more sophisticated than Apollo in some regards, maybe not. It's 50 years. That we shouldn't be spending like the astronomical, pardon the pun, sums of money, especially in the current economic climate. And I think the public backlash for this will be really interesting to watch. Maybe America will get behind it and it'll be something that they'll do their flag waving and say, this is fantastic, you know, we're going back to the moon and yada, yada, yada. But who knows? It's, I don't know what your thoughts are, Terry. I've pushed for this for years. I was really passionate about this years ago. Now it's kind of like the costs and the complete mess that Boeing have put themselves in with this, with these overruns and these issues and these technical issues. And yes, you've got to get it right. You can't just launch, and, unless you're STS1 and you do just launch. I don't know, Terry, what your thoughts are on this. I'm not as excited as I once was, shall we say.
Yeah, especially as it isn't a manned mission or a personed mission.
Yeah,
a lot depends on Nicole, the latest tropical storm, which is heading towards the Cape. At the moment, it's not a threat, but it could become a threat, and it really would be heartbreaking if they had to roll it back into the assembly building again because of what would then be basically a hurricane approaching. So they're watching it. At the moment, they say, we're keeping an eye on it. At the moment, all systems are go, but you never know with meteorology. It could become a threat, and at the moment, it's predicted to head in that direction. Fingers crossed for them. On your other point about sort of the money and the overrun and all the rest of it, in the old days with Apollo, NASA just threw whatever money it took at it to get it done. We can't really justify that now. We're probably looking at somebody like Elon Musk, much though I dislike a whole lot of what he's doing. Never mind the Starlink satellites now, what he's doing on Twitter, but we'll not go into that. But yeah, he does it for a fraction of the cost, and credit to him for that. So I hope it goes.
Yeah, we hope, we wish them well. Don't get us wrong at all. We're not anti-Artemis or anything to do with that. It'd be fantastic to see this go up, and hopefully the scientific return will be invaluable. You look at the James Webb and the cost overruns on that, but the scientific return is already paid for it 10 times over in terms of what it's already delivering. Let's just hope that the scientific return from Artemis is going to be along the same lines. Anyway, brings us on nicely to look at what to look out for. This could be one of the things to look out for, because unless you're Terry, I mean, I missed Apollo just because I was born in 1969, but you may have seen some of the Apollo first and second stages, and you only have to look at some of the exhaust plumes that are now very evident on some of the launches. It's going to be amazing to see this thing, because the launch trajectory from the Cape takes it directly over Western Europe. So potentially being able to see this go up. On top of that, what else have we got, Terry?
I'm not sure if it comes far enough north for me to see it, but you never know. I certainly didn't see any of the Apollo ones, but watching on TV now is, you're on board the rocket basically as it's going up. It's amazing. A whole lot of things that we can see in the sky tonight actually touch on some of the things we've been talking about. For example, the Taurid meteors. It's a double shower that occurs in November. The first part of the shower, the southern Taurids, has been and gone, but the next group, it will be happening over the next couple of days, with the maximum on November the 12th and 13th. They are parts of Comet Encke, the comet with the shortest known period around the sun, only 3.3 years. And they normally it's a relatively minor shower, but the interesting thing about it from the observer's point of view is that they're very long, slow meteors. They hit our atmosphere at a relatively low combined velocity, so you can actually follow them as they go across the sky, rather than ones that just appear as a streak of light that's gone just as soon as it's sort of registered on your retina. But more exciting still, there's a chance that we'll get a large number of fireballs in this shower. The American Meteor Society has calculated that you get an outburst of fireballs in this shower every, I think it's 13 years, something like that. Anyway, we're due for possibly a large number of fireballs this time around. Now, the moon will be just past full, and normally that is sort of a killer for seeing meteors because a lot of them are faint. But since in this case we'll be looking for meteors that are much brighter than average, say brighter than Sirius, perhaps as bright as Mars or Jupiter, you can see them even in relatively bright moonlight. So it's having a look at the sky. They appear to come from the constellation of Taurus, where Mars is at the moment. We'll say a bit more about Mars shortly, but they can appear anywhere in the sky. But if they are Taurids, if you trace their path across the sky backwards, you will come to the constellation of Taurus. So definitely worth a look. So we talked about meteors and meteorites. I doubt if these will actually be big enough to produce meteorites, a different sort of body, but There's nothing as fascinating or spectacular to see as a really bright fireball streaking across the sky. So look out for that. Saturn, which we mentioned in terms of Cassini, is getting quite low in the southwest, but you can still get it if you get your telescope out just as soon as the sky gets dark. And an incomparable sight with the rings. And if it's a decent telescope, you'll see quite a few of the moons too, probably Titan and a few others like Rhea and so on. Just getting, as I say, to the point where we're starting to lose it as it sinks slower into the twilight. So if you haven't seen it yet, go out and have a look, particularly with a telescope. Jupiter, just past opposition, brightest object in the night sky at the moment, apart from the moon. About minus 2.7 magnitude for those that are interested in the figures. Unmistakable, by far the brightest star-like object in the sky, relatively high up in the south. With binoculars, you can see at least 2, 3, sometimes 4 of its main moons, and easy in any telescope at all. Things like the Great Red Spot, which has been there, much bigger than planet Earth, and has been circulating in Jupiter's atmosphere for a couple of centuries. Fascinating to watch. My favorite planet to actually observe, because there are things always happening on it. Favorite one to look at is Saturn, because it's so beautiful. And then Mars, which we talked about a lot, and it is coming up to opposition when it's at its closest and brightest to the Earth in December. At the moment, it's still not quite as bright as Jupiter, and won't get as bright as Jupiter, but it's the second brightest object in the sky after Jupiter, star-like object, unmistakably reddish in color in Taurus, just between the horns of Taurus, the horns of the bull at the moment near Aldebaran, and well worth having a look. You'll not see any detail on it in binoculars, but if you have a telescope, you can see some of the dark markings, the polar cap, and definitely worth having a look, particularly when we're so interested in what is actually happening on the surface there. Yep. It will be at opposition on the 7th of December, and we'll say a lot more about this in coming episodes of the show. It will actually be occulted by the moon when the moon is full and that Mars is at opposition. In other words, the moon will slowly creep up on it and start to cover the disk of Mars. It will disappear behind the moon, and then about an hour or so later, it will reappear on the other side. So we'll say a lot more about that in coming issue. But it's fascinating to watch Mars as it gets brighter and closer to the Earth. And also, if you want to see a planet that you haven't seen before, Uranus, just below naked eye visibility. Unless you have got very good eyesight and a very dark sky, but it's coming up opposition on November the 9th. And if you have a star chart or an app on your phone or a computer planetarium program, you can find out where it is and have a look at that. You won't see very much detail in it, but it's always interesting to try and observe all the planets in the solar system. Even Pluto, if you want to still class it as a planet, you can see it with a big enough telescope. Uranus, just visible with the naked eye if you know where to look. Easy enough in binoculars. To see Neptune, you need a telescope. But have a look for Uranus. This is as good a time to see it as any. So that's what to see in the sky at the moment.
That's fantastic. And like I said, I've got... I'm going to be going over to the Blackett Observatory at Marlborough College in a few weeks. They do open evenings, and I'm associated and working with them as well. They've got an 18-inch f15 refractor. It's the largest refractor in the set. It's amazing. It's absolutely stunning, like early 1800s. I think it was built around about 1860. Mesmerizing.
Who made that one?
Oh, it's not Cook. I'll find out for you, Terry.
Right,
but
okay.
Absolutely beautiful construction telescope.
That would be a beaut.
Optically, they've had GoTo fitted. It's just going to be mind-blowing to look at Jupiter. Yep. And you look at Jupiter, and you've got to remember the Juno spacecraft's orbiting that. You look at the moons. One of those moons is the most active volcanic thing in the entire solar system. Saturn, as you said, fabulous, beautiful to see. Mars, decent-sized telescope. You can see the polar caps. You can see the ice caps on Mars. I don't know what you think your thoughts are on, Abby, if you look through stuff with a telescope, but it's a lot of fun.
Very exciting. Mine's just strong enough to see the Galilean moons that I got out the week, so I will have to be getting out and looking at some of these things this week.
Yeah, brilliant. Good luck.
Very exciting. Well, thank you to everyone who's tuned in tonight.
Okay.
For tonight's show, and thank you as ever to Nick and Terry for a wonderful show. I'm sure some people are having some apocalyptic nightmares now from that. Please subscribe to our YouTube channels and to all our social media. We're now going to be highlighting holiday gift ideas every Wednesday until Christmas, so keep an eye out for that, and you can shop for them online at our Oxfordshire store and our Didcot store. And I think our next show is going to be the 22nd, if I'm right.
Yep,
sounds good. So until then, thank you everyone for joining us, and thank you again to Nick and Terry.
Cheers, Abby. Cheers,
Thanks, everyone.
everybody.
Cheers.
Bye.
Bye.